Electrolysis of water. Electrolysis of water means that we are going to break the water compound into hydrogen and oxygen gases. As we know, hydrogen and oxygen gases combine spontaneously to form water. So if you want to make the opposite reaction, so it will be a non-spontaneous reaction. So we are going to use an external force, which in this case the DC power source. This is used to break down the water into the two gases, which are the hydrogen and the oxygen gases. So the reverse process is non-spontaneous and is forced by electrolysis. If we look here in this figure, we have the DC power source and we have connecting wires, we have two tubes, we have the water here filled in this beaker. We connect the positive terminal of the DC power source into the anode direction, and the negative terminal is connected to the cathode direction. As we said before, at the anode we have oxidation, so we have a loss of electrons, so this explains the positive terminal. Positive means electrons are lost, and at the cathode we have reduction. We have reduction at the cathode, it means we have gaining of electrons, so also this explains that we have here the negative terminal. So the water is broken down into hydrogen and oxygen gases. What are the half reactions that are found here? We have two reactions. The first half reaction, which is occurring at the cathode. At the cathode, we are obtaining hydrogen gas in this reaction. 4H2O plus 4 electrons is giving 2H2, so this is the hydrogen gas here produced, and 4OH minus. At the anode, we have oxygen gas. So oxygen gas is collected at the anode. We have 2H2O, so this is an oxidation reaction, half reaction, gives oxygen O2 and 4H plus and 4 electrons. I will show you in the next slide how can we get the overall reaction or the net reaction. So in this slide, look at this figure, it's more clear. Oxygen is collected here at the anode and hydrogen is collected at the cathode. The anode reaction is 2H2O gives O2 plus 4H plus 4 electrons, and at the cathode reaction we have 4H2O plus 4 electrons, we have a collection of 2H2 and 4OH minus. The overall reaction, since we have 4 electrons here, these 4 electrons are crossed with these 4 electrons. So if we add this to this, we have 6H2O on the reactants, and we have oxygen, we have 2H2 hydrogen gas, we have 4H plus and 4OH minus. Both together they combine to form 4H2O. Then we can cross from the 6H2O here and the 4H2O here. Finally we can get the overall reaction of water 2H2O gives 2H2 plus O2. And the cell potential is negative 2.06 volts. This negative sign indicates that this electrolysis is a non-spontaneous reaction. So the negative sign indicates that it is non-spontaneous. We need to memorize the anode reaction and the cathode reaction, and we know how we can find the overall reaction. So we are responsible about the products in each half reaction. Let's take another example for electrolysis. In this case, it's not for water. So we have seen the electrolysis of water. Now we are going to explain the electrolysis of mixtures of ions. So suppose we have a solution, a mixture of ions, and an electrolytic cell containing these three ions: Cu2 plus, Ag plus, and Zn2 plus. If the voltage is initially very low and is gradually turned up, we need to see which metals are plated out onto the cathode and what is the order. Which one is the first one reduced? Which one is the second? Which one is the third? When we say plated out, it means that it is reduced first. So if we look to the reduction reactions, if we look here, Ag plus plus 1 electron gives Ag, and the reduction half reaction, this is 0.8 volts. If we look for the copper, Cu2 plus plus 2 electrons gives Cu, this is 0.34 volts, and Zn2 plus plus 2 electrons gives Zn, this is negative 0.76 volts. From these values here, we can notice that the more positive the E, it means the more reaction has the tendency to make reduction, since these three are reduction half reactions. So, since the electrons are to the left of the arrow and the ions are to the left and the metals, the solids, are to the right of the arrow, so Ag has the highest E value, the most positive, which means that it is in the first order. It's the first metal that is plated out. So of the three reactions listed, the reduction of Ag plus occurs most easily because it has the highest value, the highest positive value. After Ag plus, we have Cu2 plus, and finally we have Zn2 plus. So Zn2 plus is reduced, but hardly. The most easily reduced ion is the Ag plus because it has the highest positive E value. When we say the reduction, it means that it has the oxidizing ability. So the oxidizing agent, as we said in the previous lesson, the oxidizing agent is making reduction. So Ag plus here is the most oxidizing agent. It has the highest ability for oxidizing. So the order is Ag plus greater than Cu2 plus greater than Zn2 plus.